All right, guys, let's go ahead and start part 2. Okay, so we're looking at the back side. Back side of page 2, problem number 13. And I apologize, I messed up some of the problem numbers, guys. I think some of the problem numbers kind of overlap. But anyway, number 13 on the back side, it says to factor the following expressions, and it gives you this picture where you have a block like this. In that block is x squared. Then you have these little blocks. It's a 1 and a 1. 1, 1, 1, 1. And then you have these guys. These are all x's. So to factor this, you're literally going to look at all of this and say, well, I have one x squared block, so I'm going to put a 1 in front of x squared, which I'm not actually writing. I have 1, 2, 3, 4, 5, 6. I have 7 x blocks, and I have 1, 2, 3, 4, 5. I have 6 1s, which add up to 6. Now just factor them. Factors of 6 that add to make 7 are what? 1 times 6, 2 times 3. I think 1 and 6 add to make 7, so I'm going to have x and 1, x and 6. Try to make a positive 7, so they're both positive. You can check your work by doing x squared, 6x, x, and 1 times 6 is 6. These two add together to give x squared plus 7x plus 6. Let me make sure that camera is still recording. I've got the other video file uploading while this is recording, so hopefully that works. Okay, let's look at the next example. Same thing. You guys have an x squared block. You have 2 x blocks. And then you have just 1 singular block. So this is going to be 1x squared, 2 x blocks, so 2x, and then a singular 1. And to factor this, same thing. What's going to make x squared is x times x. Factors of 1 that will add to make 2 are just 1 times 1. Sometimes simple is the hardest, guys. Put a 1 and 1. Try to make a positive 2, so both of these are positive. And now let's put this back together. X times x is x squared. X times 1 is x. 1 times x is x. And 1 times 1 is 1. We add the 2 x's together. We get x squared plus what? 2x plus 1. And this is our answer. Okay? All right, let's go to number, no, the answer was the factor form, my bad, x plus 1 times x plus 1, okay? By the way, I meant to mention that when you have identical factors, you need to write your answer as x plus 1 quantity squared. Not gonna be as worried about this because I didn't quite mention this to every class, so probably on the test tomorrow, I will just accept x plus 1 times x plus 1. I will think about it tonight and I will clarify that tomorrow. So number 14, we did this in class, 24. X cubed y squared minus 30 x squared y cubed plus 12 x squared y to the 4th. We're asking what number will divide 24, 30, and 12. We want the biggest number. We want the GCF, the greatest common factor. So on all your factoring from this point forward, you guys need to be asking, is there a greatest common factor that will divide all my terms? But going forward in this class and on the test, we want to be looking for this. How do we find the greatest number? We look at the smallest number. What number, the greatest number that can come out is found by analyzing first what's the greatest number that can go into 12. 12 being the smallest number in the problem. So let's go. Figure out the biggest number in 12. Start with 12 itself. 12, 24, 36. Okay. Does 12 go into 12? Yes, it does. Does 12 go into 24? Obviously, we see this in the list. So 12 times 2 is 24. But does 12 go into 30? No, it will not, because notice the list did not produce a 30. So 12 is not going to work. So what's the next biggest number that goes into 12 besides 12? Well, this requires a little bit of knowledge of your multiplication. That's 6. 6 times 2 is 12. That's the next biggest number that goes into 12. Let's write our 6's and see if 6 goes into 30 and 24. 6, 12, 18, 24, and 30. So we see that 6 will go into all three of these. So 6 is our biggest number. We're going to take a 6 out, and now we're going to ask how many x's can we take out of each term. I have 3 x's here, I have 2 x's here, and I have 2 x's here. We learned this today, guys, that I want to take as many x's as I can, but I cannot take more x's than exist in a singular term. What do I mean by this? I want to take as many x's as I can, but I have to take the same number out of every term. Can I take 3 x's out of this term? The answer is yes. But I cannot take 3 out of this one or this one because these only have 2. So the greatest number of x's that can come out is going to be limited by your smallest number of x's, meaning that the term that has the least number of x's is going to determine the limit to the number of x's that you can take out. So the greatest number of x's we can take out here is 2 because our smallest term just has 2 x's. Okay, so what do we have here? I can take 2 x's out of here, 2 x's out of here, and 2 x's out of here, so we're good to go. We're going to take 2 x's out of every term. I have 2 y's, I have 3 y's, I have 4 y's. What's the greatest number of y's that I can take out of every single term? Well, since this term only has 2 y's in it, the greatest number of x's I can take, the greatest number of y's that I can take is 2. I'm going to take out 2 y's out of every term. So let's go. 6 times what is 24? That's a 4. X squared times what gives me x cubed? Well, that's one way you can ask the question. I can say I have 2 x's multiplied by how many more x's will give me 3? That's going to be 1 more x. Okay? 2 y's, or I should say y squared multiplied by how many more y's will give me y squared? Well, if I have 2 y's, I don't need any more y's here to multiply to give me a y squared. So this term is done. Let's go to the next one. Another way you can think of this, you can say 30 divided by 6 gives me what? Gives me 5. Or you can say 6 times what gives me 30. That's another way to do it. So you can either divide or you can ask what multiplies. 6 times 5 is 30. This has to be negative. And you can either say x squared times what gives me x squared, or you can say I had 2 x's, I took 2 x's out, so there are no more x's. I had 3 y's, I took 2 y's out, so there's 1 y left. However you think of it, either way we'll get the right answer, and we will check it when we're done. Now our last term, 6 times what? This is what I prefer. I think the multiplication makes more sense. I like to think putting it together in order to take it apart, guys. 6 times what will give me 12? That's a 2. X squared times what will give me x squared? Well, x squared times nothing over here will give me an x squared. Okay, so I just need no x's over here in order for the product of the two to give me an x squared in the result. Y squared times what will give me y to the 4th? Well, if I have 2 y's here, I need 2 more y's here in order for the result to have 4. Okay? Let's check our final answer. 6 times 4, looking at these terms. 6 times 4 is 24. X squared times x gives me x cubed. Y squared times no y's in this term gives me y squared. Okay, let's check the middle one. 6 times 5 is 30. X squared times no x's here will give me x squared, and y squared times y will give me y to the 3rd. Okay, done with that. Let's check the last one. 6 times 2 is 12. X squared, there's no x's here, so I'm going to get x squared in the result. Y squared times y squared is going to give me y to the 4th in the result. Okay, so there we go. All right, so this is our answer to number 14. Okay, let's check number 15. I'm going to go a little bit more quickly now that we went through that one. Okay, number 15. Less explanation here, guys. Just roll with it. 12x squared minus 15x. We are taking out the greatest number that will divide 12 and 15. I told you guys to look at your smallest number. In this case, that is 12. So check 12. 12, 24. Well, that's not going to make 15. Okay, let's try the next biggest number that goes into 12. Let's try 6. 6, 12, 18. That's not going to produce a 15. Try the next biggest number that goes into 12. That's 4, 8, 12, 16. That's not going to work. So what's the next biggest number that goes into 12? That's 3, 3, 6, 9, 12, 15. There it is. There it is. 3 will produce 12 and 15, so we're going to take a 3 out. I have 2 x's here, I have 1 x here. The total number of x's that we can take out is what? 1x, because I have to take the same number of x's out of each term. Now we're going to ask 3 times what is 12, that's 4. X times what is x squared, that's x. 3 times what is 15, that's going to be a negative 5 because this is a negative 15. And I don't need an x on the 5 because I already took the x out. And this is our answer. Okay, and again, you can mentally check this by doing 3x times 4x gives 12x squared. 3x times 5 gives 15x. Okay. All right, let's go to the next page, last page. Okay, we are looking at number 16, x squared minus 14x plus 49. When you guys get into the factoring on the test, first thing you have to ask yourself, is there something common that will come out of all 3 of these terms? Is there a common x on all 3? The answer is no. Is there a number that divides all 3 other than 1 itself? The answer to that is no, because I only have a 1 here. So there's no GCF to take out. When there is no GCF, you're just going to factor this as is. We have a trinomial, starts with x squared, so this is going to be x times x, just like we did earlier. Factors of 49 that add to make 14 are going to be what? 1 times 49, and then we have 7 times 7. I think 7 and 7 add to make 14, so this is going to be 7 and 7. Remember, if we're adding to make 14, the signs are going to be the same. Since this is a negative 14, they're both negative. Don't forget to check your answer. X times x is x squared. X times negative 7 is negative 7x. Negative 7 times x, so again, negative 7x. And here it is. This is what makes the problem make sense. Negative 7 times negative 7 is why we get the positive 49 on the end. And also because they're both negative, that's why we're adding in the middle. So by checking your work, you guys understand what is going on here with multiplication of 2 negatives giving a positive, but the addition of 2 negatives giving what? A negative 14x in the middle, okay? So this is, nope, this is not our answer. Our answer is the factored form here, okay? All right. Let's go to number 17. 2x cubed plus 32x squared plus 128x. The first question you have to ask is there something common among all your terms? The answer to this is yes, because notice all the terms are even and we can divide all the terms by 2. Also, we have a common x on every term. So we're going to take out a 2, and the maximum number of x's I can take is going to be 1x because the smallest number of x's in any term is 1. So we're going to take out a 2x. Now we're going to ask 2x times what is 2x cubed? Well, that's going to be x squared. 2 times 1 is 2, and x times x squared is x cubed. Next, 2 times what is 32? That is 16. X times what is x squared? That's going to be an x. And then 2 times what is 128? That's 64. You may have to do 128 divided by 2. Reminding you guys to do this, you have to ask how many times does 2 go into 12? That's 6 times. 2 times 6 is 12, subtract, you get a 0, bring down the 8. 2 goes into 8 4 times, 2 times 4 is 8, subtract, get a 0. We will be reviewing how to divide more later, okay? But for right now, here's an example of division. You guys can always YouTube division and remind yourselves of these rules, okay? 2 times 64 is 128, x times no x here gives us an x. So we have successfully taken out the 2x. Now we have to ask, do we have a resulting trinomial that will factor? Yes, we have a second-degree trinomial. This factors into 2 first-degree binomials where we have x and x. Don't forget your 2x's sitting out here. Factors of 64 that add to make 16 are what? 8 times 8 makes 64, and also add to make 16. So we're going to have an 8 and an 8. Since the 16 is positive, both of these will be what? Both of these will be positive. Okay? Now to check your work, you're going to put your binomials together first. X times x, x squared. X times 8 is 8x. 8 times x is 8x. And 8 times 8 is 64. Don't forget, we still have this 2x sitting out here, so you need parentheses around this because we still have to distribute the 2x. There's still multiplication that needs to take place. That's why we have the parentheses. Let's add the 8x's together. We get x squared plus 16x plus 64. And we have the 2x on the outside. Let's go. So let's distribute the 2x. 2x times x squared is 2x cubed. 2x times 16x is 32x. And 2x times 64 is 128x. Okay? which is what we started with at the beginning. Oops, this is what we started with, so that means this is our factored form right here where we had it broken apart. Okay? Next problem. Okay, we have number 18, x squared minus 25. Remember, this is a special type of factoring. Look for this tomorrow. When you guys have two perfect squares separated by subtraction, we call this object a difference of squares. Remember, the word difference means subtraction. Remember, there has to be a negative between this to work. We will talk about when there is an addition sign between there, why it doesn't work, but we will do that later. Okay, so right now on your test tomorrow, you will have a subtraction sign between your two terms. This will be second degree, and remember, this factors very easily. How do you do this? You look at what multiplies identically to make x squared. That's x times x. What multiplies identically to make 25 is 5 times 5. This is going to be x and x. The x's go in the front, the 5's go in the back, and this is going to be opposite signs. Remember that these are called what? These are called conjugates. Identical binomials that have opposite middle signs are called conjugates. So a difference of squares factors into a product of two conjugates, okay? Now we're going to check our answer, and you'll see why this works. X times x is x squared. X times negative 5 is negative 5x. 5 times x is 5x. 5 times negative 5, here it is. Positive times negative gives us the negative 25 on the end. And notice, we have opposite terms in the middle that have opposite signs. We subtract 5 minus 5 is what? 0. And we get x squared minus 25. It works every single time. So this is our factored form answer. Okay, one more. And we're going to conclude this video. Number 19, I'm not going to go over the last four on your study guide. They're very much like what we've already done. You guys can figure that out. You take out what's common and then you factor the result. Number 19, 7x cubed y minus 63x y cubed. Notice we have two terms and there's something common among both terms. Notice 7 is our smallest number. If we write our sevens, eventually we will get to what? 56 and then what? 63. And if you count down, 7 times 9 is 63, okay? So 7 will come out. I can take 1x. I can take 1y, okay? 7 times what is 7? Well, that's 1. I'm not going to write the 1 yet. X times what is x cubed? That's x squared. The reason I don't need to write the 1 is because I have something else sitting here, so I don't need to put... The only time you'd write a 1 is if everything was gone, guys. If everything factored out. For example, if I had 7x plus 63x squared, and I took out a 7x, I took the entire 7x, and I have to have a 1 here. 7x times 1 is 7x, and then 7 times 9 is 63. I took out the x, so I would have 9x. Okay, 7x times 1 is 7x, 7x times 9x is 63x squared. Why do we have to have a 1 here? Because there has to be something there for the 7x to multiply by, okay? So that's when you put a 1. In this case, we have an x squared term still here, so we don't have to write the 1. We took the y out, okay? 7 times what? 7 times 9 is 63. We took the x out, y cubed. We took 1y out, so what's left here is y squared. Okay, we're done taking this out, and if you notice, we have two perfect squares with subtraction in the middle. This is a difference of squares. We're going to start labeling this DOS. X squared is x times x. 9y squared is 3y times 3y. So let's go ahead and factor this into a product of conjugates. This is going to be x and x, 3y and 3y, and this is going to be plus and minus. And don't forget 7xy is sitting out front. Again, you're going to have to put this back together. Guys, there's an example in the previous one to put this back together. I wish you guys good luck on your study guides, and I will see you in the morning.